Hello everyone, I'm John, and today we are going to be taking a quick look at RenderDoc. This is a utility that will maybe help you debug your this assignment you're working on and the next one, I think. And it's good to know how to use if you ever go into graphics. Now, here is the first problem. It runs on Windows and I think maybe Linux. And if you're on Mac, you can build it from source, going to GitHub and downloading all of the stuff, but that's way outside the scope of this video and it's not really supported by the development team. So, yeah. This is part of why, people say that they like working on Windows and games are made for Windows. It's because you have tools like this. Anyway, you can go to this website, renderdoc.org, and download the installer. You probably want Windows 64, right? I doubt any of you have a 32-bit machine. For Linux, you should check your package manager first to see if there is a package there, and if it's not, then you can go and download the binary from here. Once that is done, you can install everything, run the application, and you will come up to this menu, this UI. So let me delete this. So over here we have some tabs. That's your main point of interaction with the app, and a few options here. These are the default options. You can load your last settings, like once you've started your app once, you can just load them again, so you don't have to configure everything. You can save and load settings as you wish. But for now, I'm gonna do it manually, and I'm gonna go to my GLApp folder, build. I have these folders here, you might not, that's okay. Just go in here and find the executable. If you are on Linux, it's just gonna be GLApp without the .exe extension, and that's it. All right. For my application, I also needed to give it some command line arguments. Yours, especially if you're using Dr. Olano's code, yours probably doesn't. So, and from down here for now, we don't want any settings, any extra settings other than this. What you might want is to queue a capture. So basically, the way RenderDoc works is we capture what happened during a frame and then we go over it and look at whatever data RenderDoc is giving us. Now, if what's happening, if the problem is in the first few frames, you want to automatically capture, let's say, frame 0, like when the app initializes. You cannot physically do that, like you cannot be fast enough to do that with a keyboard. So you queue it here and you capture the however many frames you want. Okay, so we are gonna launch the application, and here is the application. You see that RenderDoc is injecting some extra text here. It says that you can use print screen to capture. It's giving you some frame data. If you do not have F12 or print screen or anything, or like you really don't want to interact with that window anyway, you can come back here. You can see there is a new tab and you can capture however many sequential frames you want. Capture immediately, capture them after a delay, whatever you're doing. So I'm gonna capture one frame immediately. Now, at this point, for this application, I'm probably done. I don't need this running anymore. But if you wanted to compare, let's say, how things change when you move around, you can come back here, move into the scene that caused things to happen, and you can capture another frame. Right, so now you can have these two to compare. I don't really need that, so we are gonna close this application for now. And you see here it says connection status closed, and we are gonna open up the first frame capture. In a second. Right, so I know this might be getting very confusing very fast. The timeline is useful most of the time, but here we probably won't use it, at least for the purposes of this tutorial. Also, obviously, I won't cover everything that RenderDoc can do, because that, could take days. So I'm gonna go over the basics, and if you need more, they always have documentation here with a lot of information, like they even have a how do I section, so start from there and go on. Oh, I see here that it says how do I debug a shader. You probably can't, especially on OpenGL, so that mainly works for DirectX 11 and 12 as an API, and even that is sort of a pain. So yeah, unfortunately you cannot debug a shader. Right, so the next important thing here is our event browser. You can see like it's a nested tree structure. So for this frame, we had the capture start, the context configuration, blah, blah, blah. You can see like a bunch of things happening here. And they probably look kinda familiar to you, because this is the same line codes that you write in your code. So this is what this is capturing. Right, and you can see all of this happened in this frame. Ignore this begin debug draw section. That's something that I added. You won't have it. It's fine. That's where all of the visual things we saw in class happen. Right, so you can filter this here with GL draw. So any function that starts with GL draw and whatever, there are many variations, is called the draw call. So when a draw call happens, the GPU will grab whatever state you have given it so far, like vertices, index buffers, textures, whatever, and try to generate something out of that. So if you click one of them, you can go here into, let's say, pipeline state. And after last class's lecture, you're probably more familiar with the pipeline. We have like the vertex input state, the vertex shader state. These are kind of referred to as the vertex state in the pipeline diagram you saw. You have, I don't even remember what this is. Does it say? Nope. Tessellation, geometry state, render state, rasterizer states, sorry, fragment shaders, and the frame buffer. This is not the frame buffer necessarily. This is not the frame buffer you have to deal with in this assignment. This is an internal frame buffer that OpenGL keeps and uses. And so for this draw call here, you can now go to any step of the state, of the pipeline state, and see, okay, what was happening during that state. So you can see here in the vertex input, let's say first, you can see that we have the three attributes. Right? This is what you were binding and building during your previous assignment. What slot they're in, and down here you can actually look at the buffers themselves. So if you click here that it says go, you can actually see the array as it was sent and copied over to the GPU. You can change the format here if you really want to. RenderDoc with OpenGL as configured in the application will do a good job of finding out the format and using that. If it's not though, you can definitely change it here. Don't forget to hit apply once you change it. Why would you want to do this? You wouldn't want to do it with this geometry necessarily, but like if you have a buffer that you need to see, okay, did I copy all of the data incorrectly? You can do that, especially if it's a small buffer. Let's say the plane. If you remember, the initial scene was a plane with a sphere moving around. If you wanted to check the plane buffers, you could do it this way because they're small and you can easily reason about them. If you start seeing huge numbers here, like close to uint max, which is like 4 billion something, I think. It probably means that there was invalid data copied over. Right, so we can close this tab. Let's go back to our pipeline state. OpenGL gives these buffers some, numerical identifiers. You can rename them if you want to. That's not really necessary. You can click here on mesh view and see a representation of the vertices sent to the GPU. So this is probably the columns around the main building in the castle. And you can see here, okay, so the input was this vertex with this UV, this position and this normal, and this is what I outputted. And so at the end of the vertex shader, object.vert, this is the output. You can see that it gives you GL position here and then the various uniforms that we defined. For instance, if you had a normal input here, but you were getting zeros over here, or nones, or I don't know, infinites, that would be an indication that some of your computation in the vertex shader is wrong. So there is probably something wrong with your world projection matrix, or the inverse of that, so that some multiplication there happens to produce a non-number or an infinite, and that's how you would know about it. Next, the actual vertex shader state. Now you can see them. So this is, in here we have the buffers that we're pushing in, like the index, the position, the normal, and the UV. And here we have the uniforms and potentially samplers and textures, but nothing to do that with the vertex shader here. If you don't remember what a uniform is, so let's go to object.vert. It's these things. So you have the object data and the scene data. Similarly, okay, let's say I want to see what was the values in scene data. You can go in here, hit the green arrow, and you can see the contents of the two matrices and the light direction, and then you can compare that with what you were copying over from the CPU side. So if these come up wrong, it means that something is wrong with the copy of that data. So you can look into debugging that. You probably won't have to touch anything with the rasterizer state, but if your viewport is ever wrong, or like you have front face scaling versus back face scaling and all of that stuff, this is where you would look into it. And then the next important part is the fragment shader. So in here you can see that now we actually have some textures loaded. In this case, it's just the gravel texture and some empty textures for specular and gloss. You can go and investigate them further here, like if you really wanted to. And now the samplers. These are structures that tell you how to read from that texture, basically. Again, you have your uniforms and the UBOs down here. Right? So now we'll go to the texture viewer while having the fragment shader state selected here. We'll go to the texture viewer and we will see that for our fragment shader, for this draw call, these were our inputs as we saw in the previous view, and this is what we outputted, which is basically the screen that shows up in like the picture that shows up in your screen for this assignment, for the previous assignment, right, for this application. So, right, okay, let me click this one. Like you can see, we just have the clear color and just rendered some geometry out of this. If we go here to the overlay, for instance, and say highlight draw call, you will see everything that we just draw becomes pink. And if I change the draw call, you will see how the scene is slowly built up and so on and so forth until you have the whole thing rendered. Like that last draw call here apparently is not rendering anything visible to us. So you also have the depth stencil here. This is just a buffer that tells you the depth of that pixel. This will be relevant later. And the final thing, the frame buffer, I don't really think you would have to deal with anything here. Right, so this is a very quick overview of how we inspect what happened in a draw call. Now, beyond the draw calls, if I delete the filter here, you can see there is a bunch of other GL calls happening here, like textures and binding and a bunch of stuff. So let's go here into our fragment shader, for instance, and we want to inspect what happened to the scene data buffer, because let's say we're getting wrong data. If we click on this, we can see all of the calls that have happened on this buffer so far. Now, let's say this was an index buffer. You come in here and you see the GL bind buffer, GL uniform buffer, right? And you were expecting this to be bound as an index buffer. So that means that somewhere you bound it as a uniform buffer instead of an index buffer, for example. And or you were not expecting any data to be copied over, and now you see a bunch of buffer subdata. And this is how you can debug what's happening and what's going wrong with your render. It's it's a lot of okay, let's see what's happening. Okay, this shouldn't be happening. Let me see, let me go back into my code. And yeah, it's a lot of back and forth. But this is how you do it, since all of this is happening on your GPU, not your CPU. If you make any changes to the code, like any of the CPP files and stuff, you need to rebuild from Visual Studio. You don't need to run, but you need to rebuild. So make the changes, hit Control Shift B, or go into build all or something, and this will update the executable, and then you can launch it from here again and capture a new frame to debug. Right. So, and going back into the buffer view, that happens with every resource, not just buffers. So even with a texture, we can see that we called gen textures once to get this ID. We bound it once, we gave it some images, and that's it. In here, you can find all of the resources that you have right now. Admittedly, doesn't have very interesting names. You will see that it has a low shaders. So what happens is, even though you have one shader, its object makes a copy of that shader. That's not how you would normally do it in an engine, but it produces simpler code. So that's why it's done this way in GLApp. But all of these shaders are basically the same, just different permutations and variations of that one shader. I think that's everything we can reasonably talk about in this video. I also want you to see no, I don't want to save. You can save the captures if you want to. I don't really care about them right now. I also want you to see like a a rough idea of what you're building. So if we go to Dr. Olano's code, have it here, we don't need these. Save this. No, I don't want it to save it. Right, and let's capture the frame again. What I want you to see is that you still have all of the draw calls that we just saw. Draw, and plus one additional one. That's the let's say deferred pass. And the important thing I want to, without spoiling what you have to do, is that here you can see the fragment shader texture viewer. The inputs are the same as before for this draw call, but now the outputs are these 4 in this case textures, because we also have the depth. And in the final pass, now you see that the inputs are those 4 textures. It's 3, but the depth stencil is already there if you do it properly, which I won't go into how, obviously. That's something that you have to figure out or read the tutorial. And the output is the back buffer color. Basically, it's just what goes into the scene. Right, so before, if we did this last time, let's say highlight draw call, you can see that everything in this picture was drawn once. No, like there is no gradual addition to this scene like we were doing before. And that's the benefit of this technique. I won't go more into this. I just wanted you to see a visual thing of what you were building. Right? That's all of the tutorial that I can think of so far. Feel free to ask any questions on Discord or reach out via DM and stuff. I would appreciate if you send the message like on the general chat first so others can see it. This video will stay online for however long it's needed, so don't worry about that. That's it, and good luck with your assignment.